See, next we are going to see this public questions. Prop 1ene to 1-fluoropropane. The number of carbon is not altered, but many are feeling difficult to write prop 1ene. Now we are going to see the first question. This is our public question, prop 1ene. You see how to write propene. 1ene means double bond. Here or here. I am just writing here the double bond. So for this carbon, already 2 bond is here, so CH2. For this carbon, already 3 bond is there, 1, 2, 3, so 1 hydrogen. For this carbon, only 1 bond is there, so 3 hydrogen. Okay. You can write like this also. All you like, somebody may write like this is okay. That is your wish. Okay. Now I am treating with HBr. When I treat with HBr means what will happen? The Br will come here and the H will come here. But this is not be required because the question is the fluoride is, you see the question, the fluoride is at the last carbon. So what you have to do? You have to add like this. When you want to add like this means this is against Markovnikov rule. So you have to fix peroxide because we want to follow anti-Markovnikov rule. So what is the product? You see this one, write the product. That is always favorable. You see and write the product. That is easy. Next one, the fluoride, bromide is converted into fluoride. What is the reagent used to convert bromide into fluoride? AgF. AgF, that's all. Okay, secondly, what is the question? Chlorobenzene to 2-chloro. First you write the formula, then only you have some idea. Without writing the formula means you may be confused. You see, first you write the formula 2-chlorotoluene. What is toluene? This is toluene. This is 2-chlorotoluene. You just compare. Here there is a chloride, here there is a chloride, no change. But we introduced one methyl chloride. You all know that. How to introduce a methyl chloride? How can you introduce a methyl? By adding methyl chloride. This is what is called as, Friedel-Cap's reaction, that's all. The asking is indirectly, that's all. In chemistry, they always prefer to ask indirectly, that's all. Okay, next one, ethanol. You see, ethanol to propane. You see, propane nitrile. When they say propane nitrile means be careful, don't write like this. Don't write like this. This is 1, 2, 3, 4. You should count the carbon. 1, 2, 3, 4. This is butane nitrile. Propane nitrile means 1, 2, 3. That's all, 3 carbon. But what is the purpose? You see, the OH is converted into CN. How can you do it? Directly you cannot introduce CN by replacing OH. So what you have to do? You should add HBr like this. You convert into Br. Br is ready for substitution reaction. It will readily come out. So now we add KCN. What will happen? CN will be introduced and the Br will be eliminated. That's from the compound. Okay, this question is over. Next question. Complete the reaction. You see, they are given all this one. Methyl chloride with sodium iodide in the presence of acetone. This is a catalyst. You see how easy question this one? Methyl halide plus sodium chloride. Whenever you write the reactant means you can guess the product. Guessing the product is very important. Don't think you cannot write all the organic chemistry by saying. You can guess. You see this question 2,4,6 trinitrochlorobenzene. You see 2,4,6 trinitrochlorobenzene. You see, they are given chlorobenzene hydrolysis. It can be through sodium hydroxide or anything like water. But what will happen? The Cl alone will be converted into OH. That's all. This is nothing but what? Picric acid or 2,4,6 trinitrophenol. Anything is right. So, okay. Next question. N-butyl chloride 1, 2. Slowly check while writing the formula. That is important. Check while writing with alcoholic KOH. I hope you feel very easy when you use alcoholic KOH. Why? Because usually, casually you remove HCl. That's all. Casually you can remove the HCl. You see, this is the product. That's all. Then KCl plus water. Then usually with KCl plus water. What is the name? 1,2,3,4 butanene, because of the double bond present in the first carbon. Next one, new question. You see, you have to take this formula and you should write 3 answers. One is optically active isomer. What is meant by optically active isomer? You see, you know this one. You already, I hope you know this one from your school. What is this one? Sir, carbon having 4 different groups. That is very important. It's called optically active. So, you should create a compound containing 4 different groups, containing 4 carbon. You see, one is already bromide. We are having 4. You are having 4. What will do? 1, 2, 3, already 4 is over. Then H, that's all. That's all. You see this carbon? One side is a bromide, other side is ethyl, other side is methyl, other side is hydrogen. That's why it is called as optically active compound. That's all. You check, they all groups are different. So, okay. Next one, second answer, highly reactive with SN2 isomer. That is, SN2 means you should prefer primary halide. How can you write a primary halide? See, very easy. You write straight. Straight means primary. That's all. You see, this is a condition for primary. Moreover, it is a linear. That's all. If they ask for SN1 means you should go for tertiary. SN2 means primary halide. This is a primary. SN2 means tertiary. Keep it in mind. SN2 means primary. SN1 means tertiary. Okay. Next one. 2 isomer that gives the same product. You see how difficult question this one. How can you go for? You cannot write this one. You cannot write this one. This is a wrong answer. You see, when you remove HBr, there will be double bond. When you remove HBr, this is the double bond, but both are same. So this is not possible. Then you go for this one. Iso. You see, isobutyl. Two isomer that gives the same product and dehydrohalogenation. Okay. In the first one, you see, this is the second formula. These two isomer will give the same formula. You see, you remove HBr from here. You remove the HBr from here, the product will be like this. You see, H from here and Br from here. So the product will be, H from here and Br from here. Okay, the product will be this one. It's okay. We cannot remove this H because if you want to remove this H means you have to remove the Br from this carbon. So when you remove Br from this carbon means you have to remove H from this carbon. Okay. You see this one. When you remove the Br from this carbon, you have to remove H from this carbon. You are getting the same product. You are getting the same product. So these two are the isomer. This is nothing but isobutyl bromide. This is nothing but tertiary butyl bromide. So okay. Next one, we are going to the next level. Alcohols, phenols, ethers. We already completed halide. In halide, what I have completed? Book back question followed by public question. Now what I am going to do is, I am going to see the book back question regarding the alcohols, ether and phenols. Then after this, I will go to the public question. So, okay. You see, first question. Using this one, you treat with HBr. This is an ether. What is the concept here? What should you say? Sir, the halide will join to the smaller group and H will join to the larger group. That's all. Mind it, while breaking the ether with HBr or HI, the halide should join with a smaller group. If you learn like this means you will answer any question, even in NEET also. So you have right answer. You see, I am writing the answer. That's all. You see, this is a smaller group with an halide. What about this one? Here also ether, here also breaking the formula. But this is a big group. You see, this is a big group. This is a small group. So what I will tell, ethyl will be joining with, you see, ethyl will merge with bromide and H will join with a ring. Third one, nitration. What will be nitration? First of all, you should have this idea. What about anisole? It is an ortho-para directing group. Similarly, anisole, like anisole, phenetol is also ortho-para directing group. You see, phenetol is also ortho-para directing group. I am writing 2-anisole, one for ortho, other para. That's all. The name are very simple. Ortho-nitroanisole, para-nitroanisole, but this is a major product. And this is a major product. Okay. Next one. Next question. You see this one? If anybody write like this means, what does it means? Tertiary butyl. You see, they are writing this group shortly, that's all. This is tertiary butyl group with ethyl group. They are giving ether. So this is a ether with HI. You see, this is a very important area. This is very important area. Why? I already told you the I should join with a small alkyl group. But here I am just cancelling my concept. What is the concept here? In this case, whenever you have a tertiary butyl means the I will join with the tertiary butyl to form this answer. You see, to form this answer. This is against the concept. You see, this is against the concept because there's a reason here. Because when I join with the tertiary means this becomes highly stable. Tertiary butyl carbocation is highly stable. So the I will merge with tertiary butyl. For this purpose, they are asking this question. Many will write OH here. As per concept, many will write OH. The concept will not work for tertiary butyl. So, okay, next question. Given benzene, sulfuric acid and sodium hydroxide. They are given 3 reactants, but they want to prepare phenol. How it can be prepared? You take benzene, it's okay. You treat with concentrated sulfuric acid. First of all, you'll get sulfonic acid. It's okay. Whenever you use sulfuric acid, it is sulfonation. Okay? When you treat with sodium hydroxide, because they are given sodium hydroxide also, it will convert into the sodium salt. So, okay? Now you do the hydrolysis. You do the hydrolysis, so the sodium salt will be converted into phenol. Okay. Next question. You see, highly technical question. These questions, third question is highly technical. Why? Because what are they telling is, you want to prepare this compound from a particular suitable alkene. First of all, it is very difficult to write this formula. Sir, how to write this formula? What I used to say, you first write the parent compound. You first write the parent compound. Parent compound is ethanol. You see, this is the parent compound. What they say, 1 phenyl. You see, 1 phenyl. This is 1, this is 2. 1 means you remove one H and replace by a phenyl. This is the formula. But for your convenience, you can change the formula as you like. That is your own thing. That is your wish. Okay. You see, for your convenience, you can change this formula like this. You can change the formula like this. Now, I am going to write an alkene to prepare this compound. I am going to write an alkene to prepare this compound. How? You see, I am removing this H, I am removing this OH. Why I am not removing this H and this OH? Because these two are from the same carbon. So you should remove OH from here means you should remove the H from here. So you see the product from here, C6H5, CH, double bond, CH2. This is the reagent. This is the reactant. Now what you have removed? Water, then you add that water. That's all. Acid hydrolysis. If you write like this means, how you will remove? You should remove the OH from here, from this carbon, and the H from this carbon. So the double bond will be here. So, okay. This is the compound used for preparation of, that is 1-phenyl ethanol. Second one, cyclohexyl methanol. You see, cyclohexyl methanol. First you write methanol. What is cyclohexyl? This group is called cyclohexyl. That's all. This is not benzene. Benzene means you should add double bond. So you remove one H and write the benzene ring. That's all. This is cyclohexyl methanol from the alkyl halides. From the alkyl halides. I am going to do as usually, you remove the OH from here and remove the H from here. This is the reagent. Used for, and as usual you add water and you do that hydrolysis. Cyclohexyl methanol by alkyl halides. Okay. Next one, pentane 1-ol using alkyl halide. Pentane 1, 2, 3, 4, 5, like this. Very easy. 1, 2, 3, 4, 5. You write the Br. That's all. You see, this is the reagent used for the preparation of 1-pentane 1-ol using the alkyl. 1, 2, 3, 4. I'm sorry, you see, I just made a mistake here. Whenever there is a group, you should write CH2. So 1, 2, 3, 4, 5. So this is 1-bromopentane. So, okay.